In this video, let's understand what is statistics and what are their definitions of the statistics and the introductions and types of statistics, descriptive statistics and inferential statistics and their key concepts, where all statistics used, its scope and types of data. Let's start this. So the statistics word probably derived from a Latin word with status, and Italian word statista, and German word statistic, which means in a political state of the political state. And the two people representing in the pictures are the father of statistics. Sir Ronald is a father of statistics, and in India, Prasanta Chandra is a father of the Indian statistics. Sir Ronald Fisher is a father of statistics. And let's come back to definition of the statistics. So basically, statistics is nothing but collecting of the data, organizing it, representing it, and presenting it, and interpreting from the collected data. So the raw data, making the raw data into any useful information for aiming the decision making or interpreting something is nothing but an statistics. Let's understand the few definitions of statistics given by several people, and also the where is the statistics interpreted from, etc. So as you know, the statistics is a collection of data analyzing, organizing and presenting and predicting and etc. All these is about statistics. Few of the definitions were given by people like Lovett or Boddington or Costin Covden are several definition. For example, statistics is a science of estimates and probabilities is defined by Boddington, and similarly, Coxton has defined as the science which deals with the collection, data and analysis and interpretation of numerical data is given by Croxton and Cowden. So basically, stats is a part of mathematics, how you have geometry, algebra and trigonometry, etc. It's a statistics is one, and in that you have descriptive and inferential statistics. What is descriptive statistics and what is inferential statistics, I will explain here. So inferential statistics is nothing but where you predict from a sample. So if you have in a bigger population here as represented in the picture and a sample, you conduct a sample on the six individuals and interpret the data or predict inferences about the entire population. That study is called inferential statistics. And descriptive statistics is which a raw data is made a meaningful data. Along with that, you identify mean, median, mode, variance, standard deviations, lot of things, skewed data, or basically you will organize the data and analyze the data in a such a way where is a range, what is a standard deviation, what is an average mean, what is an average median, etc. All these you discover in descriptive statistics. These all words in future videos you will understand in details. This is about types of statistics. And let's go to the next topic is which is scope. Application of statistics, where where all it is used in all the verticals, right, starting from business to the sports, education, finance, information technology, social studies, social service studies, and technology, social sciences, etc. All where engineering, everywhere it is used. These, once you define your KPIs and once you start collecting the data, you can do the wonders around the statistics for the multiple areas. Example I can give in information technology. If a software is delivered to the production, how many defects were identified, what are those? And similarly, what is the traffic of the network, how do you are getting, what type of testings you are doing, where all the defects are coming from. All these are in depth. If you go, these statistics things are applied. And similarly, hypothesis testing also. Similarly, if you take in a healthcare or a medicine, you apply You do certain types of hypothesis testing on a certain sample and apply to the and predict the for the population, entire the population. All things are these are everywhere the statistics is used in all the industries and verticals. And let's understand the types of data. So basically, types of data are nothing but you have a quantitative data and qualitative data. Quantitative data have two types, which always talks about the numbers. So qualitative indicates a number, which is a discrete qualitative data, and continuous qualitative data. The data which is countable, like number of defects identified in the production or number of customer complaints which have come or something like that, which easily derived from the data, is nothing but, or number of students available, a number of students in certain college of statistic students, something like that, is an a qualitative discrete data. And continuous data is nothing but where you derive it, something like temperature, you apply a formula and get it, and a length or something like that. If you try to do it, that is called qualitative continuous data. And quantitative continuous data, similarly you have a qualitative is nothing but in a categorization. It's in a kind of a how many males participated in the survey, how many females participated in the survey, or different categories. Yes, no, true, false, all these are called attributes. So which talks about the qualitative data. So let's move on to the, before collecting the data, what are the data collection methods or sample collection methods? So there are different types of methods where you collect the data. One is through surveys, where you post some queries and ask the public to write about it. And similarly, experiment, you do the experiments on certain sample within a controlled variables, where you do draw impact effect or cause effect relationship between the phenomena. And similarly, observational studies, in observational studies you don't do anything, you just observe raw, naturally you are observing and writing down the behaviors. These are the different types of the data collection. You can call as a third party data or in a first hand data or primary data. You can call, my primary data means is nothing but where you have collected the data on your own via samples or surveys or experiments or observations. That is called in a primary data. Where you get a secondary data, that means some other party has done, you just got the data, that is called secondary data. So these are the different types of data. So let's move to the next topic, which is limitation of statistics. So statistical methods are best applicable to the quantitative data, which are in number. Basically, it gives you an almost in a right prediction or right thing in this. Statistical decisions are subject to a certain degree of error, meaning it is not an 100% accuracy. It gives 99.99 or 99.9. It's a subject to a certain degree of an error. Somebody can show the this is type of error which has occurred, something like that. Statistical laws do not deal with an individual observations. It's all about a group of observations. Statistical conclusions are true on an average. It is not 100% across. It's a true on average. Statistical is liable to be misused. If the data itself is wrong, and if you are trying to predict with the formulas, etc., which are applied, and if you are trying to do, the conclusion may vary. The conclusions may manipulate it. All these are the limitations. So there is a chance of manipulating, and there is a chance of having a data misleaded data. So these are the limitations of the data. Next comes the concepts, key concepts of the in statistics. So first we'll deal with the frequency. Frequency is a number of times in a particular value or a range of values in a data. It is counted multiple times. That is called frequency, and it is represented with f, small f. For example, if you see 24111, so 111 is repeated. So this column is called frequency data. Similarly, cumulative frequency. Cumulative frequency You should have frequency. Then the next columns comes the CF, which is called cumulative frequency. You just add the frequency of each value till the end of the data set. Example, you have a frequency here 2 and 4. The same example, 2 is the first one comes this as it is, but the second cumulative frequency adds up the first value, which is 6. 6 plus 1, 7. 7 plus 1, 8. 8 plus 1, 9. So it goes on like this. Next comes the relative frequency, which is represented with RF. Relative frequency is nothing but a range or a particular value divided by number of data points. Basically, it is calculated by dividing frequency by a value by number of observations in a total number of observations, not numbered. It's a total number observations. Okay. And let's move on to the example, relative frequency. For example, we got 2, 4, 1, 1, 1. So you need to add all these values. 2, 4 plus 6, 6 plus 1, 7, 7 plus 1, 8, 8 plus 1, 9. So 2 by 9 is nothing but 0.222. Similarly, 4 by 9, 0.444. 1 by 9. Like this, if you do it, this is called relative frequency. You should not add by number of values. You should add by number of total number of values. You need to sum up of the frequency, and from each frequency divided by the total number of frequencies is relative frequency. And next comes the cumulative relative frequency. So it is an extension of relative frequency. You have given a frequency, then a cumulative frequency, then CFR. CFR is nothing but each one cumulative frequency divided by the total number of observation. This is your formula. Cumulative frequency divided by total number of observation. Cumulative frequency. First, you need to identify cumulative frequency. First row remains the same value. Then 5 plus 10, 15, 15 plus 7, 22, 22 plus 3, 25 it becomes. Now, the value is 5 by 25, 15 by 25, and 22 by 25, and 25 by 25. This is a cumulative relative frequency, which is represented by CRF. With this video, we'll stop about the introduction to the statistics.